Hello physics students, this is Mr. Downing. I'm giving you some extra help here on this motion graphs project. So here are our instructions. For motion graphs, we're going to color code each section to mark them as separate from each other. And then for each section, we want to be able to describe the motion and tell what is happening. We want to be able to find the slope of each section on distance or velocity graphs. This is not necessary for acceleration. We want to be able to find the area under the line of each section on velocity and acceleration graphs. Then there'll be a question at the bottom. We want to be able to answer this. We want to show our work. So first, let's look at this distance versus time graph. Distance versus time. Now we can see that there's three distinct sections. So let's just color code them real quick, just so we can see that they are different from each other. Now this is helpful just because whenever we're looking at, say, slope of the line, we'll only look at the slope for one section. So I said that these are distinct from each other. So first, it's important to remember this is distance. So everything we say is going to be about distance. Okay? So let's look at some of our rules for distance. So for distance, if distance stays the same, it is not moving. So if you're not changing your distance, you're just standing at the same distance away, you're standing still. If your distance is getting more positive, positive means forward. So if your distance is increasing in the positive direction, you're going forward. But if the distance is getting more negative, that means it's going backwards. And if distance is a straight line, you're at a constant velocity because you're constantly moving forward at a steady slope. If distance is a curved line, that means it has acceleration because your slope is changing. So let's look at this distance graph. So for this first section, the distance is getting more positive, so it is going forward. Now this is a straight line, so if we want to describe this motion, we said it's moving forward at constant velocity. Okay? So for this section, we would say, let's go ahead and put this as like an A, B, C section. Okay? So it's section A. We are moving forward at constant velocity. We know forward because it's getting positive. We know constant velocity because it's a straight line. Okay? If we describe B, if distance stays the same, it is not moving. So distance is staying the same, therefore at B, it is not moving. Okay? At C, once again, my distance is increasing. It's a straight line, so it's constant velocity. I'm getting positive, so it's forward. Now, another way to think about these lines is think about the beginning and the end. So you can say at the beginning, I am 10 feet away. At the end, I am 50 feet away. This makes it a little easier to tell our story. So if we go from 10 feet away to 50 feet away, clearly we were moving forward. So see, again, moving forward at constant velocity. Okay? Now we also need to find the slope, because this is a distance graph. We're finding slopes in all of our distance and all of our velocity graphs. Now we need to find the slope of each section. Every section is going to have a different slope. So whenever you find the slope, my slope is rise over run. Now the more technical way to say that would be y2 minus y1 over x2 minus x1. In physics, we just say delta y over delta x. Now, the 2 and the 1 lets us know we have to have 2 points. So pick out easy ones. So for this first section, which I've done in blue, I'm going to pick out 0, 0 as my first point, and I'll pick out 10, 10 as my next point. So for the blue section, A, if I do y2, that's 10, minus y1, 0, over x2 minus x1, sorry, that's 0, 2. 10 minus 0 over 10 minus 0, my slope is 1. Okay? So here, my slope equals 1. And now in this case, my slope, my change in y over my change in x, That's a change in distance over a change in time. So in this case, my slope is a velocity. Okay? So this velocity is my slope. Now in B, I could calculate this slope, but any flat line, the velocity is 0. The slope of a flat line is always 0. Now if I go here, okay, I have this point right here at 20, 10. And I have this point, let's see, follow down to 60, 50. So if I do y2 minus y1, so I'll do 50 minus 10 over x2 minus x1, 60 minus 20, so that's 40 over 40, that's still 1. So my velocity is 1 meters per second. Now that I found the slopes of each part, what is the velocity at t equals 40 seconds? Well, 40 seconds, so I don't find the velocity to this point. I cannot do I can't do 30 over 40. That would be wrong. 30 over 40 is not a slope because that doesn't have 2 points. Okay, it's not just y over x, it's y2 minus y1 over x2 minus x1. So I can pick out this 40 and 30 point, and I have to use another one. Now, I could use any 2 points, the first and end, any middle. Just pick ones that are easy to get clean numbers for. The velocity here is 1. The velocity is not 40 over 30. I'm sorry, 30 over 40, 0.75. That is not my velocity. The velocity on the distance versus time graph is the slope. Okay, let's go down to this velocity graph. So I'm going to color code my sections. It doesn't matter what you're using here. This is just to try to make it easier. You can just use 2 colors. You can use 5 different colors. You could use a pen and a pencil. It really does not matter. It just kind of makes it easier for us to see. Okay. So we have these different sections. Now, if we're going to describe the motion of a velocity graph, velocity has some different rules. So my velocity rules. If my velocity stays the same, if I have a flat line on a velocity graph, that means I'm moving at a constant velocity. I am maintaining the same velocity the whole time. I'm still moving though. If my velocity is positive, it's forward. If my velocity is 0, it is not moving. If my velocity is a negative value, it is moving backwards. So on this graph, any of these times above 0, we're moving forward. Right here, whenever it crosses the 0 point, for this moment, we're stopped. And all these points down here that have negative velocities, those are all moving backwards. Okay? Now, if the velocity is going up away from 0, it's accelerating forward. If the velocity is going down away from 0, it is accelerating backward. Anytime the velocity approaches 0, if the velocity approaches stopped, that means we're slowing down. We're slowing down to 0. We're slowing down to stop. So let's take these rules and let's go back to our graph. Okay? So for this first section, so I'm going to call this A, B, C, D, E. Might be convenient doing a separate sheet of paper. Here, my acceleration is going from, my velocity is going from 4 and it's staying at 4. A flat line, if velocity stays the same, it's constant velocity. And it's positive, so it's forward. So this is moving forward, constant velocity. B, this is a little trickier. So it is a straight line, so that means we have some acceleration. I'm sorry, it's not flat, but it's diagonal. It's a straight diagonal, so we have acceleration. Now we're starting positive though, and we're ending negative. So it means we were going forward, we stopped, and went backwards. Because it was positive, and then it was 0, and then it was negative. So we were moving forward, slowed down to stop, and then we accelerated backwards. Okay, if we look at the next part of the graph, here it's a flat line. That's constant velocity. But the difference is my velocity here is negative. So now I am moving backwards at a constant velocity. Okay? So I think you're getting the hang of this velocity. Follow these rules. Think about, this is a velocity graph. So think about what velocity means. You can't just say it's going up, because going up on a velocity graph is very different than going up on a distance graph. Okay? And you can't just say it's the same. What's the same? Velocity is the same. So here, this flat line on a velocity graph, velocity stays the same. So we're moving, in this case, backwards. Moving backwards at a constant rate. Here, yes, this is the same, but what's the same? Distance. So if we're maintaining the same distance, that means we're standing still. Okay? There is a third kind of graph. These are the most rare. These are acceleration graphs. So acceleration is much simpler. So for acceleration, we only have a few rules. So if acceleration is positive, that means we're speeding up. If acceleration is negative, that means we're slowing down. Now this assumes that my velocity is greater than 0. So if I have a positive velocity to positive acceleration, that means I'm speeding up. If I have a positive velocity and negative acceleration, that means it's slowing down. If my velocity is negative, it flips all these rules. Now if my acceleration is 0, if I have no acceleration, that means I have no change in velocity. So that means I'm moving at constant velocity. Okay? So on this acceleration graph, we still have these sections here. So this is acceleration versus time. So we can see all these points of acceleration are all positive. Now, remember, these are accelerations. So my acceleration is increasing. So now I'm increasing acceleration. That means the rate at which I'm speeding up is increasing. So I'm speeding up even more here than I was here. Now here, a flat line on an acceleration graph, that means I have a constant acceleration. I'm still speeding up, but I'm speeding up the same. So this is constant acceleration. Now, remember, these are positive numbers, so they are forwards. Now, here, we're asked a different question. So we looked at the slopes before, but if we go back to our instructions, we're going to find the slope on any distance and velocity graph, and we'll find the area under the line on the velocity and acceleration graphs. Now, I didn't do the slopes here on this velocity graph, but you would need the slope of each section. We already practiced slopes in the distance graph, so I hope you can do the slopes for each section here. Remember, pick out any 2 points, y2 minus y1 over x2 minus x1. And then we find the area under the line. Since it's a velocity graph, we do that here too. Okay, so let's do that on my acceleration graph. So I'm going to do it for each section. Okay, so I'm going to do this section right here, this section right here, blue section, yellow section, and the green section. Okay, I'm going to go ahead and color these in because I think that's going to make it a little easier for us to see what shapes we're working with. We have this triangle here. We have a rectangle there. On these odd shapes, you need to think about them as a combination of 2 shapes. Okay, so think about them as if we divide the shape right here, and it's a triangle and a rectangle. Find the area here and the area there and add them together. Same thing's going here. Okay, so we can find the area of this triangle A triangle area is 1/2 base times height. So the height goes from 0 to 2, and the base goes from 0 to 1. So if I do 1/2 base times height, the area here is 1. And now the area of an acceleration graph is velocity. Okay? Let's write down that rule too. So slopes take us from the slope of a distance versus time graph will tell me a velocity. And the slope of a velocity versus time graph will tell me an acceleration. There's nothing after that. That's why we don't find the slopes of acceleration graphs. Areas, if I have an acceleration graph, if I find the area under the line of an acceleration graph, it'll tell me a velocity. If I find the area of a velocity graph, it'll tell me a distance. There's nothing after that. That's why we don't find the areas of distance graphs. So this should help you label what they mean. So the slope of a distance graph is velocity, slope of velocity graph is acceleration, and vice versa for areas. Okay, so I need to go find the area of each of these sections. So I'm going to skip ahead. I'm just going to do one more. What is the change in velocity between t equals 3 seconds and 5 seconds? So when they say velocity, and this is an acceleration versus time graph, to find velocity, we need to use the area to get from acceleration to velocity. So when they say between 3 and 5 seconds, they really want the area of the blue section. So first, I'll find the area of this rectangle. So this has, rectangle area is length times width. So the length from 3 to 5, that's 2. The width is from 0 to 2, that's 2. Okay, so the rectangle area is 4. And now my triangle, the 1/2 base times height. Let's see, my triangle base goes from 3 to 5. So I'll get 1/2 times the base is 2. And the height goes from 2 to 4. So that's 2 as well. So 1/2 times 2 is 1, times 2 is 2. So I'll add those sections together. So the velocity is 6. The area of this whole part is 6. Now you will need to show all your work. Make sure you have everything neatly labeled. I recommend using an A, B, C, D, E kind of thing and numbering these graphs as the first graph, the second graph. Maybe do this on a separate sheet of paper. Do whatever you need to keep it organized. Make sure you're following all the instructions for every graph. Color code each section. Describe the motion for every single section. Find the slope of every section if it's a distance or velocity graph. Find the area under the line for every section if it's a velocity or acceleration graph. Then make sure you're answering the question. Last bit of advice. Whenever you're finding the area under the curve, you're always going all the way to the 0 point. Don't just go to the bottom. So look where this line 0 is. It might be at the bottom. It was here. That's why we went all the way to the bottom here, because 0 was this bottom line. On this velocity graph, this 0 line is right in the middle. So whenever I go back to find the areas here, I'll go all the way down to there. But when I go over here, I need to go that way. Let me color these in, you can see it a little better. So those are the areas I'm finding. I'm not necessarily going to the bottom of the graph. I'm only going to the 0 point, wherever it's at. And so when I find the areas here, I would be finding distances. Okay? So distance graphs, velocity graphs, acceleration graphs. Slopes take us from distance to velocity to acceleration. Areas take us from acceleration to velocity to distance. Think about what distance means. If distance stays the same, it's not moving. If distance is getting more positive, it goes forward, negative, backwards. If my distance graph is a straight line, that means I have a constant velocity. If it's a curved line, it's accelerating. Now those are very different than velocities. If velocity stays the same, I'm moving at constant velocity, but I am moving. If velocity is positive, it's forward. Velocity is 0, it's not moving. If it's negative, it's moving backwards. If the velocity is going up away from 0, we're accelerating forward. Down away from 0, accelerating backward. If velocity is approaching 0, it's slowing down. In all of these cases, if my velocity changes, that's acceleration. Acceleration graphs don't come up as much. If acceleration is positive, it's speeding up. If it's negative, it's slowing down. If it's 0, we're not changing our velocity at all. Okay? Follow these rules, interpret these graphs. There's a lot of information to pull off of them, so they're very dense. They can get very sloppy if you don't stay organized. So do what you need to do to keep all this information straight. And remember, these graphs have meaning. Don't describe to me the line. They represent something in the real world. So represent and describe a real object.